Bismillahirrahmanirrahim. My dear students, welcome with the new lecture. Guys, today we are going to talk about summary of ATP synthesis. You have just a single molecule of glucose and you can proceed the further process and going to your Krebs cycles, Krebs cycles, electron transport chains. But the first steps you must know that will be always your glycolysis. Splitting of sugar. In glycolysis, during your Krebs cycle, and during your electron transport chain, the actual ATP formation will always, but I don't have to say that will always, because you are under some stress. The formation of ATP synthesis will be disrupted due to some other factors like environmental factors, like internal genetic factors, and maybe some other factors. The formation of ATP will disrupt due to any external and internal body factors. But the actual amount of ATP you can obtain from a single glucose molecule during a normal situations will be 30, not 36. But in your textbook, the Punjab curriculum course is showing that 36 ATP will be found by using a single glucose molecule. Okay?
Yes.
So, look at this. This is the first process, glycolysis. During glycolysis, 4 ATP formation takes place, while out of these 4, 2 will be used within this from our starting during the first step of glycolysis, while you produced 2 NADH plus H plus, while there is none of the formation of FADH2 will take place. So you have a total of 2 ATPs and 2 NADH plus H plus, while there is no FADH2. Pyruvate oxidation, the first step of Krebs cycle, natural Krebs cycle. This is natural Krebs cycles. Pyruvate oxidations is separate from the Krebs cycles. So, in the pyruvate oxidations, you can obtain only 2 NADH plus H plus from 2 pyruvate molecule. Okay? So the third one is your Krebs cycles, and during the Krebs cycles, 2 ATP formations will take place, while 6 NADH plus H plus, while 2 FADH2 will be found over there. So the basic reasons behind these 30 ATPs, you can look at this, that during electron transport chain, when this all NADH plus H plus will go over there in electron transport chain. So 1 NADH plus H plus will give you 3 ATPs. What the actual amount of this? 3 ATPs, okay? While FADH2 will give you only 2 ATPs. But the case here that you have plasma membrane, you have mitochondria. What is this? Mitochondria. You have matrix, the inner membrane, the inner mitochondrial membrane, and this is the C site, your perimitochondrial site. Okay?
Yes.
Perimitochondrial site. Okay. So you need to travel something from here to here. Okay?
Yes, sir.
You need to travel your proton from your matrix site to your perimitochondrial site, that is cytoplasmic site. This process must need to spend some amount of ATP. If you can obtain 3 ATP by oxidizing a single molecule of NADH plus H plus, and you can obtain 3 ATPs, the 0.5 ATP will be spent in their traveling from here to here. Okay?
Yes.
So, by this you have 8 NADH plus H plus, which are traveling from here to here. But 2 ATP, 2 NADH plus H plus, traveling from your cytosol to the inner side of membrane and then matrix. Okay, so this 2 and this 6 NADH plus H plus traveling from here to here, and when they traveling from here to here, they will spend 0.5 ATP. 0.5 ATP from matrix to C site. But when they traveling from here to the outer side of membrane, they will spend 1.5 ATP. To the matrix. The 2D mitochondria, okay. So now you have 8 NADH plus H plus, which are traveling from here to your C site. So 8 multiplied by 2.5, and the actual amount raised here 20 ATPs. 2 traveling from this side to this one, multiply over 1.5, you will obtain 3 ATPs. Okay?
Yes.
Now FADH2, the same case about FADH2, that 0.5 ATP will spend when